Exercise 8.1, Problem 7, Discussion. Let's read the problem. The radii of two right circular cylinders are in the ratio of 3:2 and their heights are in the ratio of 5:3. Find the ratio of their curved surface areas. So let's mark what's given. Ratio 3:2, that is ratio of the radii is 3:2 and 5:3. The ratio of the heights is 5:3. Anything else is given? Yes, it's a cylinder. Okay, I guess that's all. So let's list it out. Radii of cylinders equal to 3:2. Their heights are in the ratio of 5:3. Okay, now let's find out what is asked in the problem. Find the ratio of their curved surface areas. So we need to find the ratio of the curved surface area. That is curved surface area of the first cylinder divided by the curved surface area of the second cylinder. Need to calculate ratio of curved surface areas. Okay, now let's find out the formula. The formula is CSA is equal to 2 pi RH. Okay, this is the only formula because we are asked to calculate the ratio of curved surface areas. Instead of giving you absolute values as it has been done in the past, where they say radius is 10 centimeter, height is 50 centimeter, etc., etc., they have given here the ratios. So this is a new type of problem, and let's find how to do it. But what we can do is, okay, I'll explain it in the steps. Okay, like step 1. So let's take the radius as 3y and 2y. It is told the radii of the cylinders are in the ratio of 3:2. That is, if one is still 3y, the next one will be 2y. That's how it will be in the ratio of 3:2. So let R1 be 3y and R2 by 2y. Similarly, height, the H1, that is the height of the first cylinder, be 5z, and H2, height of the second cylinder, be 3z. You might be wondering why I am not using x and I am starting with y. The problem is x, we are using it here for multiplication symbol, so that is why we are not using, so we are starting with y. Okay, so let's take R1 as 3y, that is the radius of the first cylinder is 3y, radius of the second cylinder is 2y. Okay, next. Calculate curved surface area of the first cylinder, CSA1, by substituting values of R1 and H1 in the formula CSA equal to 2 pi RH. So all we need to do is, in the place of R we will put 3y and in the place of H we will put 5z. So then we will be able to get the value of CSA1, that is the curved surface area of the first cylinder, in terms of y and z. Repeat the same step for the second cylinder. That is, calculate CSA2, curved surface area 2, by substituting values of R2 and H2. R2 is 2y, H2 is 3z. Okay, in the formula CSA equal to 2 pi RH. Then again, in this case also, we will get the curved surface area of the second cylinder in terms of y and z. Then the last step, all we need to do is divide the CSA1, the right hand side, by CSA2, that is the right hand side of this equation, and you'll be able to get the ratio of the curved surface areas. Okay, it's a little tricky, don't worry, try to do it, and if you can't do it, come back and see the solution. Okay, let's look into the solution. So let the radii of the cylinders be 3y and 2y. It's given the ratio of the cylinders, ratio of the radii of the cylinders is 3:2. So let's take R1 equal to 3y and R2 equal to 2y. So it's in the same ratio. 3y is to 2y is nothing but 3:2. Similarly, H1 as 5z and H2 as 3z. Okay, CSA is given by 2 pi RH. Now, first step, substitute the value of R1 equal to 3y and H1 equal to 5z in this formula to get CSA1, the curved surface area of cylinder 1, which now becomes 2 pi into radius is 3y into height is 5z. Okay. Similarly, curved surface area of the second cylinder is 2 pi R2, which is 2y, and H2, which is 3z. Okay, now all you need to do is divide equation 1 by equation 2. So CSA 1 divided by CSA 2 will be equal to 2 pi into 3y into 5z divided by 2 pi into 2y into 3z. Okay. Now if you look at this equation, this 2 pi 2y will get cancelled, y and y will get cancelled, z and z will get cancelled, this 3 and this 3 will get cancelled, the left out will be only 5 by 2. So that is the ratio of the two curved surface area. CSA 1 by CSA 2 equal to 5 by 2, or the ratio of the curved surface area equal to 5:2. You can write a ratio as 5:2 or 5 by 2. If it is a fraction form, it comes as 5 by 2. The ratio form, it is 5:2. So that is all in this problem. Only thing which is different here is that they have not given you absolute values. They have given you ratios. In such cases, assume them to be multiples of y, x, y or z. So the ratio here is 3:2. We are taking the radius as 3y and 2y. Similarly, here we are taking it as 5z and 3z. Only thing is that what symbol you are using here must be different from what we are using here. We cannot use the same y for this also. If you use y here, you will have to use z here. If you use a here, you will have to use b here. That's all it is to be taken care here in this particular problem. Okay. That's it in this problem. Thanks for watching.